So here's what a packet looks like on the internet. We have a protocol that defines how packets are sent on the internet. It's called IP, Internet Protocol. I know, most creative name ever. And the protocol defines the format of a packet, of the data that's in a packet. So a packet is a bunch of bits, a bunch of data with some predefined format. And there's a header. The first, I don't know, what is that? 20 bytes, I think, is typically the header. And the rest is the payload. And you should think of the payload as the message, the actual message that you're trying to send, the contents. And the header is something to help get that packet to the eventual destination. Okay, so this is now a little bit more sophisticated version of what I started off with, showing you how you communicate on a shared network. An IP, there's a bunch of fields here. For instance, there's the source and the destination address. We saw something like that before. But there's other stuff in there as well. Like, for instance, there's a checksum so that you can detect if there's been some corruption to the data, there's been some error. So the analogy to think of this is like an envelope where the header is like the stuff on the outside, that's like the addresses and so on. And the payload is like the message that you write on the note inside the header. So when host A wants to send to host D, they're using the Internet Protocol to get there. So we're going to need some way to identify the host we want to get there. And for that, we have the IP header, the header here for the Internet Protocol. And here's what's in the IP header. I'm going to show you mostly IPv4. IPv4 is kind of like the old, yesterday's version of what powers the Internet, and probably still the majority of end hosts are using IPv4. There's a next generation called IPv6 that we're trying to shift to that's better in a bunch of ways. I'm going to mostly focus on explaining to you how IPv4 works. IPv6 is similar in a lot of ways, so you'll get the main ideas. So what is there in this header? There's various stuff. For instance, in this header, you can have a variable length payload, a variable length data there. So there's a length field that says how many bytes of payload do we have. We need to know who this packet is destined for. So there's a 32-bit destination address, a destination IP address that identifies uniquely the machine that this is destined for, and a source address that uniquely identifies the machine it came from. Also, this payload might be TCP data, might be UDP data, might be something else. The recipient is going to need to know how to interpret it, so there's a protocol field. This 8-bit protocol field in the middle indicates how to interpret this data here. Basically, what protocol, what format is this payload data in? Okay. So in IP, we have IP addresses, which are how we uniquely identify machines. Each machine has a unique IP address. And in IPv4, they're 32 bits long, which isn't really long enough. If you want to have more than 4 billion machines, that's not enough, which is one of the reasons why we introduced IPv6, which has 128-bit addresses. But for IPv4, it's 32 bits. Each host has its own IP address. And the packet has both a source and a destination. The reason why the packet has the source address in there, it's not for the benefit of the routers. The routers actually ignore the source address. They only look at the destination. They don't look at the history of how the packet got to them. They only care for the future, right? It's like great life philosophy, right? Don't obsess over the past. Just think about where you're going in the future. The reason the source address is there is so when the eventual recipient receives this, they know who it's from, and if they want to send a reply, they know where to send the reply. So the analogy, if you like this postal mail analogy, the way you can think of this is that what's on the letter is the header. The post office, when figuring out how to get this letter to the recipient, doesn't look inside, doesn't open up the envelope and look at the contents of the letter. They're only looking at what's printed outside. So that's like routers only looking at the header. And in IP, all we have for the recipient's address is an IP destination address. And all we have for the sender's address is an IP source address. So there's no structure there beyond it's a 32-bit value.